Okay, so here's the syllabus. Let's just talk quickly. We finalized our office hours. We're both in ECA, which is the building right across from the bookstore and the computer center, right across the street. I'm on the second floor. Owen is on the third floor, 348. Here are our hours. I'm Tuesday 10 to 2 and Thursdays 2:30 to 3:30. He's Wednesday and Thursday 12:30 to 2:30. So probably with quizzes being on Fridays, this is good. You got a Wednesday off, Tuesday with me, Wednesday with Owen, and then we both are on Thursday. And you can catch us all the way from 12:30 to 3:30 on Thursdays, okay? And then I'm also by appointment, and Owen is too, okay? So I should have talked more about the textbook. Does anybody have the cellophane wrapped thing with them? Does anybody have the physical copy of the textbook? No one brought it. No one has it. You took it back. Okay, yeah. So there's two options for the traditional textbook. The first option is just buy the online My Math Lab. That's sufficient because all the textbook is online. So the online My Math Lab gives you access to the online homework and an online text. That's option one. Option two is to buy the bundle where you get all that, but then you also get a physical copy of the text. And it's like $8 more or $9 more. So if you're someone who really likes to have a physical copy of the text, you just pay a little bit more and you can have that. So either one. But what you need is some version of the text, either online or in hand, and the access to the online homework. And either of those options do it for you. Just My Math Lab online access or the bundle with the book. You will not need, there's a recitation notebook that you can buy separately. We won't use that, so don't buy that. Okay, questions on that? So that textbook we'll be using more in the second half of the course. Okay, but we'll just all get enrolled soon here in the first month, so we don't have to worry about it when we start using it. Okay? We know that Blackboard is the home base. You've already found that. Okay. The instructions for getting your copy of Graphing Calculator are now up on the announcements on Blackboard. Okay, so everyone, so by Friday, you should all get that downloaded onto your main computer. If you have a laptop, put it on your laptop, and then you can bring your laptop to class. If you don't have a laptop, then whatever computer you're using at home, put it on that, whatever your main computer is. Okay? So special dates, those are just dates for everyone along the way. So homework. Homework will be collected in class, and also we'll have online homework more in the second half with the My Math Lab. In terms of getting homework in on time, so I'm not going to accept any late homework, and then what I'll do is I'll drop some at the end of the semester. Just too many students and too much to juggle. So even if you have the best excuse for why you made it to class but you don't have your homework, it'll just be one of the ones that you drop and it won't affect your grade. Okay? So you have a cushion for things out of your control. All right? So don't abuse that. Like if you use all those up, you're not going to turn in the homework because you've got these. Well, then at the end of the semester, you may have some emergencies that come up, and now your cushion is gone. So the ones I drop are for things out of your control. All right? So you don't have to email me and come talk to me about late homework, because I'll just say no. That'll be one of the ones you drop. Okay. Again, so much of your grade with homework will be like effort, organization, coherence, and then there will be a component of it that is correctness. Okay. But we're looking for like professional work that you're turning in. That's a big part of the grade. So quizzes, we'll have quizzes. You'll have quizzes in recitation, except during the weeks when you have tests. So the weeks that you have tests, we won't cancel recitation, but there won't be a quiz the day after the test. Okay? Okay, so the Math Testing Center. So the pretest is today or tomorrow. And for all the tests, including the pretest, you're going to go downstairs in the basement, PSA 21, and you need to have a valid Sun card. For this pretest, you won't have a calculator, okay? But for the other exams, you can bring a calculator. The hours are, the door is open between 10:30 and 6:30, and then you can work until 8:15. So sometime today or tomorrow, you're going to go down there to PSA 21 with your Sun card and take this pretest. Okay, so carve out an hour. Most of you will take less than an hour. Okay? And then here's our test schedule. It's still tentative. I'm still waiting to hear, but I don't think there should be a problem. We're going to have tests on Thursdays. And the final is Thursday, May 2nd. We will be taking attendance. Attendance is mandatory. And then, so here's the weights for grading. You can check that out. And then I do use a plus and minus scale. That's there. And then there's the basic policies for all university and department classes. Any questions about this kind of stuff? So you have a homework for me today, is that right? So here's what I want you to do. Whenever we turn in homework, take all your pages. All your pages like this, okay? And what you're going to do is you're going to, okay, and so getting this right is part of the grade. If you don't get this right, so homeworks are all out of 20 points. Owen, if you don't get this part right, Owen will deduct 5 points from 20, okay? It's very easy, but it just takes a little effort, okay? All right, so here's your homework, front page. So you just take it and fold it right down the middle towards yourself like this. Like a book, okay? And then after you're done with that, you're going to turn the open side to the right, not the left, to the right. Now you're looking at this is the right side of the back page. And in that upper right-hand corner, on the back of the last page, that's where you're going to put the head. So holding in your hand, it looks like this. Yes? Here's where the heading goes. Upper right-hand corner of the back of the last page. The heading will just be name, 270, and date. What's the date today? 1/9/13. And the heading will go right there in that corner. If you blow this, 5 points off. Yeah? Is there a question? Just stack them all up, facing you, fold it right towards you. This is the front page. Fold it, turn it right. And that looks like this. So this is very helpful in many ways. One way that it's helpful is if you forget to staple it, your papers will stay together. That's one advantage to it. But there's others as well. Yeah? What's that?
For the heading.
Just write somewhere around there. Just in the middle, or you got some space there. You can do it. Just somewhere here, anywhere here. Okay, does it make sense? We'll always do it that way. So then once we're ready, let's pass them forward. So sometimes we will talk about some problems in the homework. I'll just briefly mention, so the idea today was that there's not really a right or wrong answer. There's more like there could be very poor answers to very good answers. There's a continuum. And could be many different ways to have a good response on these questions. All right. Oh, the other thing too is if you would, in the future, so if you're already past it, so give me a clean left edge. Give me a clean left edge before you fold, okay? But if you didn't today, that's okay. That's it. Incredible. If this needs to soon as you're done. Go ahead, them all. I'm out of rubber bands, sorry. I normally have rubber bands, but I'm not. Okay. Questions on nuts and bolts stuff? Okay, get out a sheet of paper. I promised you a quiz. Again, if you can give me a clean left edge, that's always helpful. No, you're not going to fold quizzes. Just homework. Yeah, don't fold this. Okay. So just put your name and let's see here. Let's do name 270. Same thing. Name 270 date. Okay, here we go. According to the reading for today, which two operations are most important in calculus? You're going to pick two of these and then explain what they represent, what the two represent. Okay? 5 minutes, go. And then I'm going to call attendance during this. So just raise your head and make eye contact. That'll be good. Where's Jacob? Colin. Colin Barnabas. Not here? Olivia. Jingwen. Did I say it correctly? Jingwen Kao. Yeah. Hu Chen. Can I help you?
Literally just signed up for this class. What should I do for this?
Right, just write that.
Just write it.
Yeah.
Thank you.
Hui Chen. Hui Chen. No. Okay, so you're not Jingwen Kao? You're Jingwen Kao. How about Hui Chen? Not here. Okay. Autumn Coleman.
Here.
Peter Collin. Thank you. Hayu Deng. Did I say it right? Hayu? Tyler. Adonijah? Did I say it right? Oh, wow. Julie Duran. Samantha. Hai. Did I say it right? Hai. Chen Rui. Chen Rui He. Daniel. Herder. Anthony. Ignacio. Elizabeth Judd. Tyler King. Heng Ku. David Lee. C. Lee. Andrew Locus, or Laux. Stanley Lubansky. Zhu. Is it Zhu? How do you say your name? Is that you? Okay. Rohit. Manis. Rohit Manis. Nicole, I saw. Richard Martin. Katie Massey. Megan McCrea. Marcus Mitchell. Judith Murphy. Andrew Myers. Adelaide?
Yes.
Did I say it right?
Yeah, I
Adelaide. Ramazan.
I use Helios.
Helios. Okay, thank you. Chunzi. Did I say it right? Chunzi. Savannah. Lauren. Different Lauren. Jatia. Did I say it right? Jatia. Chelsea. Lauren Ryan. Cindy Salgado. Stephanie Sandoval. Daniel S. Schleicher. Amos Shi. Connor Simpson. Christopher Solis. Daniel St. Germain. Joshua. Ivan. Corey. Christina Trin. Which one's Trin? Okay. Lionel. So.
Here.
Wanting Wang. Z Wang. Tylea Windsor. Sharon Wu. Christina Zambrano. There we go. Ki Zhao. Is it right, Ki? Chi? Okay. Say it one more time for me. Say it one more time for me. Okay. I have a friend who's a doctor in Chinese. He can help me. Okay, I think should be enough time. Yeah, so make sure name 270, 1, 9, 13. Don't fold this. Fast forward. But in the future, ask that at the beginning. Now we're turning it in.
I see somebody else writing it, so then I thought about it.
Whenever you hand something in, if you're tearing it out of a notebook, give me a clean left edge, please. Clean left edge. Thank you. Okay, what was the first one on the list that the reading said was subtraction? And what does subtraction represent? Okay, so it's a difference. True that all subtractions are differences, but then what does that final answer, what does it represent? Okay, was it?
How much greater or less another number is.
Okay. Someone. Okay.
Change in quantity.
Yeah. So, and that's all, they're all saying the same thing. So, the change in a quantity, from the starting to an ending, some starting to ending point. Okay, that's subtraction. What was the other one that the reading said? Which one? Division. Division. And what did division represent? What does it represent? How fast a quantity is changing. Rate of change. Okay? Okay? So let us. Any questions on that?
Do you give partial credit for all or nothing?
What's that?
Is it all or nothing, or are you giving?
I'm not sure. It's not a major component. It's not a major grade. It counts for a little bit. Okay, just want to make sure you're reading. So, what about this? What about this? If what operation gives us a scaled version of another quantity? That's multiplication. So that wasn't in the top two, but it's still very important. Okay. In fact, this is where we build division from. So a scaled version of another quantity is the result of a multiplication. Okay, so here's an example. A tree shadow is 2.8 times as long as the tree is high. Okay, and then second example, the number of checkers in 12 rolls is 12 times as large as the number of checkers in one roll. Okay, so we talked last time, we introduced this idea of this type of graph, these horizontal bars. We're going to be working a lot with these. The purpose of these is to help us to reason about the quantities and how they change. Okay? So the reasoning, the process is just as important, if not more important, than some final answer. Okay? We talked about traditional math instruction, and there's a heavy focus on getting an answer, right? Getting an answer. But we're going to really focus on the process, what your thinking is in the process. So these bars, how can we use these bars to represent this situation right here? A tree shadow is 2.8 times as long as the tree is high. So
The tree could be the bottom of the bar.
what about the tree?
So the tree has like a certain height, I guess.
What's that?
That height is fixed to be the smaller one.
Okay, he said that he wants the smaller one, this one at the bottom, to be the height of the tree. So it's not the tree. This isn't the tree. It's the height of the tree, right? The quantity related to the tree. Okay, and so then what could the top bar represent? Somebody else? Does it represent the shadow? The length of the shadow. The length of the shadow. So how can we use these bars now to see the idea of multiplication or a scaling of one quantity to get a scaled version of that quantity? How can we use those bars to see that?
Use the bottom bar as an arbitrary measurement to separate the top bar.
Okay.
So draw a line. Yeah.
All right. And then what?
And then do another one that's similar right there.
Okay.
That should be that's how it showed that it's scaled.
Okay. So this is the height of the tree, and so the length of the shadow is how many heights of the tree? So 1, another 1, and 0.8. So which is the scaled version of the others? The shadow, the scaled version of the tree? Or the height, the length, the scaled version of the height? Or the height, the scaled version of the length? The length is scaled up. It's the height of the tree scaled up by 2.8. And so what do we take the height of the tree? We multiply by 2.8. We're scaling it up till we get a scaled version, which is what the shadow represents. So 2.8 times height equals shadow. Nice and easy to start, right? Okay, how about this one? The number of checkers in 12 rolls is 12 times as the number of checkers in one roll. So why don't you just take 30 seconds, talk to the person next to you. How can we use these bars to represent this situation and specifically multiplication or scaling? Okay, go.
And then you could deduce what number of checkers. Like if you know how many rolls is one roll.
Right. Because you're breaking it out the same size as the one.
Right, so the bottom is a single roll. Top is 12 rolls.
Okay, what does the bottom bar represent?
One roll. The number of checkers in one roll.
Does it represent a roll, or does it represent the number of checkers in a roll?
Number of checkers or checkers.
Number of checkers in one roll. Okay, and so then what does the top bar represent? Number of checkers. That's not going to work. So my hand with this pen, I have good days of handwriting and bad days of handwriting. All right, so that number of in one roll is at the bottom, number of 12 rolls is at the top. So how can we then use that diagram to see a scaling or represent multiplication? Somebody new? Let's see here. Where's Connor Simpson? Connor here?
Yes.
Tell me.
You repeat the question.
Yeah, sure. So now that we've established that's the number in one roll and that's the number in 12 rolls, this top bar. So how can we use the bars to show that this is representing multiplication or scaling?
Just divide the top bar into 12 sections. Each one of them have to be 1-to-1 scale the bottom bar.
Okay. So pretend that's 12. There's 12 sections, right? Okay. And so how does this showing multiplication? Lauren? The whole thing?
No, which Lauren?
Yes, you. Yeah.
Okay.
Yeah. Sorry. Yeah.
That and the amount of checkers in the row to scale it up to get to the next one and scale it up by 12. You get
Yeah. So you're going to take number in one roll, multiply it by 12, or take 12 of them, multiply by 12, scaling it up to get the number in 12 rolls. Piece of cake, right? But have you ever thought about that before? That's what multiplication is. It's you taking a quantity and you're scaling it to get a new scaled version of that quantity, like magnifying it or shrinking it. Okay. Any questions? Okay. How about this? A car travels 67 miles per hour for 5.1 hours. Okay, so I'm going to let you loose here, but I'll just warn you, this is a little bit different. So you got to think about it. How are you going to represent this situation here with these bars that I'm showing you here? Okay, car travels 67 miles per hour for 5.1 hours. So give it a shot. If you want to work with the person next to you, you're welcome to do that. How are you going to use the bars to represent this situation and multiplication? Yeah.
Do we have to use those exact bars or can we make different sizes?
Okay.
so every 1 hour we do
The,
No, we're just trying to
like how big I made this one doesn't really matter in this case.
It's not what
Yeah. But just something similar to this. Something similar to this.
67 miles per hour. So which one should we do?
This is different. This is different. Okay. So what does the bottom bar represent? Okay. And what does the top bar represent? Okay, so instead of having both be distance traveled, let this one be hours and this one be distance traveled. Redo it. So what's the first question you have to settle before you start? What's the first question you have to settle before you start?
Which bar are to represent miles?
Yeah, so what quantities the bars represent? What quantities the bars represent? So that's what we have to settle before you start.
Oh yeah.
The top would be total distance traveled.
Other videos? Yeah. Thanks. Thank you. Yes. Yeah. Thank you very much.
No. 67 miles per hour is how many miles they travel. So then the top would be total distance traveled. This is 67 miles. 5.5.
Okay.
This
This
is
is what I suggest. Make the bottom bar number of hours and the top bar distance traveled. Take it from there. Take it from there.
That's 5.1.
Yeah, right? Not me. Not total. Yeah, right now. Oh, yeah.
Okay, where's Katie? Katie. Okay, so did you make some progress using these quantities for the bars? Okay, so the whole length of that bar is the total miles traveled. Is that what you're saying? Is that known here? Do you know what that is? I mean, you can find it, but it's not immediately given, okay? So I think that's good. So seeing that that length of that bar is the total distance traveled, then what next? So the length of that bar is, we want to make it number of hours. How many hours would the length of that bar be? Yeah, we'll make that the 5.1. Okay, so somebody new. Nicole? So if I make it, this is going to be the total distance traveled by the car, and this bar is going to be 5.1 hours. How can I make progress now? Where should?
Well, I went and already did the multiplication, and I just made that top bar equal to the total amount of distance traveled in the 5.1 hours. 341.7 miles.
So the multiplication is what we want to kind of expose and reveal. So
You could just, in that case,
So-
you could just put it as 67 miles per hour. Is the top bar?
So how are we gonna? So what does this 67 miles per hour mean? What is the meaning of that?
Are we gonna separate the bottom bar by like one by one, and every piece is gonna be equal to 67?
So what I'm hearing you say is I want to do this right here. And what length of time is that?
67. 1 hour.
See, this is a time bar, right? So this is 1 hour.
Yeah.
And then 1 hour, you're saying?
It's gonna be equal to 67. 67 miles per hour.
So 67 miles per hour means that in every 1 hour, you go 67 miles, right? So these are corresponding lengths here.
Yeah.
The 1 hour here corresponds to 67 there. So what is our scaling factor? What are we scaling by?
Scaling by the number of hours, 5.1.
She says 5.1. We're scaling by 5.1? We're taking 1 hour and we're scaling it by 5.1. How does that help us find the distance? Because in 1 hour we go, so we're going to scale 67 by the same amount, right? So if we're scaling 1 hour by 5.1, and we know that every hour is 67, we're going to scale 67 by 5.1 too, right? So we want 5.1 67-mile segments. This is how many we want. 5.1 of these 67-mile segments, and that's multiplication. Can we quit there? Is that okay? He says it's okay. Is it okay just to stop there? Is it uncomfortable?
We should go through and finish everything.
It depends on if they want to know the complete distance that you travel.
What is that distance? Nicole, you said what was it?
341.7.
Is 341.7 more correct than what I have in the box?
No.
Just a different representation, right? This is so as a final answer, that's perfectly fine. It may feel a little uncomfortable, but it's this. There's no difference between these two. They represent the same thing. This just actually one advantage to this is it shows the process. It shows that this value is a scaled value. Okay, it's these 67-mile segments along the road representing 1 hour scaled up 5.1 times. Okay, questions on that? So what is getting scaled here? So this is different than those previous ones. What's being scaled here? What quantity is being scaled?
Both.
What's that?
Both the number of hours.
Both are getting scaled, right? Before it was one bar was a scaled version of the other. Those were constant quantities. Those were unchanging quantities. The length of the shadow, the height of the tree. And now we're talking about changing quantities. Distance traveled is changing as time goes by, as time is changing. And so we're scaling both of them simultaneously. As we scale the number of hours, we also scale the distance. So you see how that's different? Question?
Can I expand on that? Are we like the top bar is the same with that, and the bottom bar is 67 miles per hour. So the bottom is the top is 5.1 times than the bottom.
Okay, so you made them both distances. You had the distance traveled in 1 hour and the distance traveled in 5 hours, 5.1 hours. Yeah, that's another way. That would be another way to do it. You could have them both be distances, and then this would be the distance traveled in 1 hour, and then the distance traveled in 5.1 hours. Sure, that's legitimate. Yeah, but I wanted to show you this way. I wanted to show you how we're scaling two quantities simultaneously. Okay, but yeah, that's totally good. Okay. Go for it.
We on our own now, or we're free to talk with
Yeah. Unless I say otherwise, you can always work with other people.
Okay.
So we want to. Where's Megan McCrea? Is that you? So how many hours do we want this lower bar to represent? What do you think? Okay. What's that? So do we want that to represent 0.002? Yeah, so if we make it 1, then this can be a part of that, right? So if it's 0.002, then we don't have an hour to compare the 67. We only have that little part. So and where do we go from there? Yes, sir?
The big bar, therefore, is 67.
So this whole thing, the big bar now is 67 miles. Okay, what now? Are those corresponding quantities? 1 hour corresponds to 67 miles. Okay, now what? DJ? Like here? Right there. So this is 2 1,000ths of an hour. So then how far do we go? Not a number, but how far do we go? How many miles do we go then in 0.00? 2 1,000ths of 67. So we're scaling 67 miles by this shrinking factor. Like this is a shrink now. 2 1,000ths of 67 will be the number of miles we'll go in 0.002 hours. Multiplication, scaling the number of miles down to a sliver of it. The same sliver of 1 hour that 0.002 is. Make sense? Okay, so let's do division. Yeah, I try to get rid of those. So I was handed these PowerPoints to someone else. I try to get rid of those because they're so distracting. Okay, all right, so here's division. The relative size of one quantity to another. So building A is 17 meters tall. Building B is 5 meters tall. Building A is 17 fifths, 3.4 times as tall as building B. Okay, so what I want you to do is you make an illustration of that. Go, make an illustration of this situation. So. So on this one, if you want, you can make your bars vertically because it's kind of like a building, right? So make your bars vertically if you want instead of horizontally. Where's Tyler King? Tyler, how'd you get started on this one?
I drew out the lines vertically, so you have building A and building B. There you go.
Okay.
And then I kind of drew the lines across so that building A was scaled in units of building B. So you
Okay.
had 3 lines through there, and you had the last 2 boxes at the top left over.
Okay.
So it's 3.3 and 2/5 the size of building A,
Okay.
which is the same as 17/5.
Okay. Nice. All right. What am I showing by these squares? What is represented by? So now I've turned the bars into these bars that are now delineated. So what does each square represent, Marcus?
1 meter.
1 meter. Okay. So let's look at building B. So 1 square for building B here is 1 meter. What is 1 meter relative to building B? Some people are saying 1/5. So 1 meter is 1/5 of building B. How many 1/5 of B does it take to make building A? 17. And another way to write that is 17/5. And we get the number . So thinking back, what did this number 3.4, when we were thinking of it in terms of multiplication, now we're thinking in terms of division. What did this number 3.4 mean in our multiplication? What part of the multiplication process was that? So yeah, some people say scaling, how much we scaled it up, right? So the result of a division is like a scaling factor, okay? Or, in other words, the relative size of one quantity to another. A relative to B is 3.4 times as long as B, or tall. So the building A is 3.4 times as tall as building B. So that's its relative size. Okay, another way to think about this relative size is measuring one quantity in terms of another. How is the number 3.4 measuring one quantity in terms of another? How is the number 3.4 measuring one quantity with respect to another?
Measuring building A with respect to building B.
Yep, so we're using the units. We're saying if building B, the height of unit building B is a unit, that's 1 unit. Now we're measuring building A in terms of that unit. And how many building Bs does it take to make building A? 3.4, right? Okay, so that's what division represents. It represents the relative size. A is 3.4 times as tall as B. Or another way to think about that is measuring one quantity, the height of building A in this case, with respect to the units of another quantity. So if building B is our 3.4 unit, or our unit for measuring A, it takes 3.4 of those to make building A. So that's the result of a division. Okay, so 3 things you've got for Friday. First is take the pretest. The second thing is, so that's today or tomorrow in the basement. Second thing is you got another homework assignment posted on Blackboard. And the third thing is download graphing calculator. Let's do that soon. Do that before Friday, so if we have trouble, we can get the kinks out. Don't forget, some of you are new to the class. Every class here's Blackboard. Every class is recorded, and I'll post the video on YouTube, and you can rewatch the video of class by going to the class video section. Okay. See you Friday.
Question for you.
Yeah.
My laptop is needing repair right now, and
Okay.
it's supposed to be back right now, but it's not back. So, am I going to need